Hello and welcome. Hope everybody's staying safe in these uncertain times. We're really excited today to bring to you this discussion where we're going to talk to you about bringing internet to your embedded device in a way that's seamless, scalable, and secure. I'm Kaushal Vora, Director, Strategic Partnerships and Global Ecosystem at Renesas Electronics. And I'm joined here by my co-speaker, Mohit from ARM. I'll let Mohit introduce himself.
Hi Kaushal, hi all. Thank you so much for joining. My name is Mohit Kedia. I'm a senior product manager and working on Pelion IoT at ARM. It's great to have you on this discussion about bringing internet to your things in seamless, scalable, and secure fashion.
Thanks, Mohit. All right. So, in this highly digital, hyper-connected age that we live in, really, some of the expectations that we have from our endpoint devices, and also some of the design challenges that are there with these endpoint devices, can be quite daunting. So basically, some of the core design challenges that we see in the IoT space are security, complexity, and scalability. Security, as in, how do we really start with security early on? Security is not something that can be sprinkled on later on in the design phase, and it's really important to start with security and from a very initial stage when you do your selection on the hardware and software side. The second important factor is complexity. I mean, IoT is pretty demanding and a very dynamic space with a lot of different requirements for rich user interfaces, different connectivity options, and a lot of different sort of compute and sensing intensive things that need to run on small compute devices. These typically end up being sort of a puzzle or a maze when you have to put things together in terms of the embedded software itself, or the hardware features, which kind of devices do we need to select, and then what kind of services and platforms can we pick in order to basically enable the end-to-end connectivity piece. And then finally, it doesn't stop with one device. The important part with IoT is how do you really scale to millions of devices, and what are some of the challenges that exist there. Teams today are highly limited in terms of resources and time. We're constantly challenged with getting devices out sooner, with shrinking project timelines, as well as the skill sets that we have, right? It's sometimes hard to keep up with so many things changing on such a dynamic basis. So it's really important to pick the right platforms on a hardware and software side that give you a great starting point, and really give you a good kickoff into this development flow. So let me talk about some of the key hardware platform features, some of the things that you need to take into consideration when you're picking the right hardware platform. And then after this, I'll give it over to Mohit to talk about the software piece. So on the hardware side, really, the hardware forms, one end of the security, right? The chain of trust that goes all the way from the device, extending into the edge, and in the cloud side, as applicable. The main root of trust lies in the device. So having strong foundational security on hardware is critical. Looking for things like, does the hardware support, secure element like features? Does it have dedicated isolation mechanisms to basically isolate secure and non-secure functions? Are there strong security tools and reference solutions that essentially show you how to implement some of these security use cases? And then, are these features, or is this architecture endorsed or certified by a third party or by a standards body? Those are some of the things that would be good to look at when you look at security very early in the implementation phase. The second piece to look at is flexibility and scalability. Is the hardware platform scalable? Is it flexible? Is the software architecture open? Do you have the ability to choose the real-time operating system or middleware of your choice? Do you have the option to roll in your own custom solution? And also, oftentimes, it's important to check if the hardware platform is supported by a strong third-party ecosystem, which is often very useful in sort of accelerating different aspects of the design by providing some building block solutions that would be applicable to the overall system. And then finally, is the platform enabled and optimized for IoT? Are there broad range of options for connectivity, both wired and wireless? Is the software architecture built for IoT? Are options available all the way from ultra low power to high performance? Because it's whenever we start off, right, we never know where we're going to end up. So having that scalability on the hardware side to go up and down in performance and power and feature sets is a critical criteria to pick the right hardware platform. So I'll give it to Mohit now to talk a little bit on the software side.
Thanks, Kaushal. It's said that hardware is hard, but in IoT, software can be pretty complex. It's typically known that the software development takes much longer than hardware development in the case of developing an IoT product. So, what are some of the key factors in selecting IoT software platform? The one that I commonly hear about is flexibility, making sure that you as a developer have a choice and availability of deploying an IoT software um, at your choice, which means either on-premise, public, or private cloud. Also, reduce the vendor and technology lock-in in terms of software and support any cloud and any devices at whatever you want. Time and cost is also a very important aspect. You want to ensure that you are reducing the development time and cost. You should look for a software platform that is complete pre-integrated solution across, starting from devices up to edge. You also want to ensure that the field cost of operating an IoT device and the maintenance of those IoT devices, the cost associated with that is lower. You should look for a software platform that is optimized for IoT, not just derived from a general web. IoT needs significant more optimizations such as power, such as bandwidth, and resource consumption on the hardware side. You also need to ensure that the security provides you, or you get end-to-end security, and it is optimized for IoT. And finally, as Kaushal said, you need to ensure that your software platform is built for scale. Scale is very important. Often we see that it's easy to do a proof of concept for a couple of devices or tens of devices, but when you want to scale them to millions of devices, it's challenging. You need to ensure you select a software platform that scales, and it is not the software platform is not just easy to do development, but while doing production such as factory flow or factory provisioning, software platform allows you tools to make that process easier. Back to Kaushal.
Thanks, Mohit. So, we discussed some of the selection criteria or some of the things to keep in mind when you, want to pick the right software and the hardware platform, which are extremely critical, when you need to get started, in the early architecture phase. Here's an example of a hardware platform that's really, built for IoT. So this is the Renesas Advanced or RA 32-bit microcontroller family from Renesas. And some of the high-level features, as you can see on the slide, are pretty much in line with some of the selection criteria that we talked about. It's built on, of course, ARM-based technology. So you have a highly scalable set of devices, all the way from ARM Cortex M23 devices to M4 and M33 class cores, which also include the trust zone based advanced isolation security. Um, Overall, these devices also have a built-in secure crypto engine or a secure element type functionality, which essentially allows you to provide end-to-end hardware-based security, whether it's cryptography, whether it's isolation engines, whether it's if you want to do certificate-based, key-based exchanges, random number generation, etc. All those things and a variety of those things are built in hardware. Along with that, connectivity options, the family supports excellent range of wired and wireless connectivity applications through Renesas as well as third-party ecosystem solutions. And then on the software side, it comes bundled with a package known as the flexible software package, which essentially is a flexible and open architecture to essentially support your development and get you really started off with your development. And by the way, we also have support for Pelion out of box with this device family. So let's talk a little bit about the RA family. So the RA family, as shown on this chart, is a very scalable has a very scalable lineup. It's subdivided into four subfamilies, RA2 on to RA8, and there are hundreds and hundreds of devices across the board with different feature variants. So there's really always the right device for whatever price point or whatever feature set that you're looking for. The RA2 family tends to be our low power family based on M23 cores, extremely efficient. Support for some options provide support for rich analog functionality for sensing applications, as well as some wireless capabilities. And we also have some devices on our roadmap that would be specific to metering, which is one of the use cases that we'll discuss. Going on to RA4 and RA6. RA4, again, slightly higher performance, mainly focused on sensing and wireless applications. RA6 is really our advanced performance device. Essentially, when you're looking at things like motor control, or high-end system control, wireless, human-machine interfacing with graphics, things like that would be suitable for RA6. RA8 is a roadmap product, but it's supposed to be a very high-end family, and you'll see more announcements around RA6 towards the later end of next year. So I talked about security, right? So the RA family itself is really built around security and security for IoT. So it has the hardware-based secure element and isolation engines and hardware. We also provide solutions and reference designs which are listed there to essentially show you how to implement some of these things, like how do you implement secure data at rest? How do you implement boot loading securely? How do you provision a device identity, for example? The MCU comes basically with the complementary software on the FSP side, which has optimized drivers for cryptography functions, as well as an alignment on the ARM ecosystem with multiple solutions available from our ecosystem partners. And adding to that, these devices are certified for CAVP for the cryptography functions, as well as ARM PSA certified at the device level. I talked about the flexible software package. So essentially, it's a really open and comprehensive software platform that encompasses by default Amazon FreeRTOS and a bunch of middleware components, HAL, BSP drivers, etc. We will be adding support for Microsoft's Azure RTOS in a few months here. And then it has the flexibility for you to use any RTOS of your choice or roll in any RTOS that you would like. And then it has out-of-box support for the Pelion client through our ecosystem partners, which we have an ecosystem of over 50 partners. Giving it to Mohit to talk a little bit about the Pelion platform.
Thanks, Kaushal. So Pelion is a platform for secure IoT device management. It allows you to quickly build large-scale, secure, and future-proof IoT solutions. So what is Pelion? What does it do? It allows you to quickly develop an IoT device. It allows you to connect IoT device to the internet, and it allows you to securely manage the life cycle of an IoT device. In order, while you are developing an IoT device, you would typically add Pelion Device Management client. It is already pre-integrated with the Renesas RA platform. You would add that client as a part of your device. It would help the device to connect to Pelion Device Management. Pelion Device Management would enable provisioning, secure connectivity, as well as device management of that IoT device. And ultimately, it allows you to have a very simple web interface to your business application or to your, to your web application, so that you can bring the IoT device into your application. Pelion enables chip-to-cloud security. It allows customers and developers to have end-to-end security right from chip to cloud. During the development time or on the device at the security, we support different options for root of trust, from the low-level security to the highest level of security possible. Root of trust is enabled using PSA. We ensure that the device keys are provisioned securely and it cannot be stolen. We also ensure that the firmware which is loaded on the device while development and also while doing a firmware update is trusted. We ensure that the firmware comes from a trusted source only. The key management is done using PKI. PKI is a very advanced key management methodology which is typically used in web. We are optimizing PKI to bring it to IoT. We allow secure onboarding of devices, and only eligible and legitimate devices are allowed to connect to the web, so that no illegal devices are able to connect to your web. Also, from a device management perspective, we provide firmware update. So if there is any security flaw in the device firmware, when it is in the field, we allow it to be fixed. And you also get to monitor your devices in the field, just to ensure that they are behaving as per the expected behavior. So Pelion and Renesas is enabling many IoT use cases, right from energy and utilities to consumer electronics to industrial automation. Today we would going to talk specifically about one use case, and we would going to do deep dive into the connected metering use case. So as you know, connected metering presents a significant market opportunity. Today, there are more than 2 billion electric meter deployed, and only 700 million out of 2 billion are connected. So there are more than 65% of meters not connected, and that's the opportunity that we are looking at. We are looking at 1.3 billion devices or 1.3 billion electricity meters. Similarly, there is a huge opportunity for water and gas meter also. ARM and Renesas enable end-to-end solution for utilities and connected metering. We provide support to key connectivity technology. We provide support to optimized mesh and point solution designed by the wireless technology leaders. And both of those technologies are something that we have been working for several years. Our solutions are open and standard-based. Our goal is not to lock you down into one solution, is to provide you with an open standard-based solution so that you have choice of selecting any component of your choice. All of it comes with the highest level of security. We have designed the IoT platform with security in mind, with security as one of the top priorities. We provide physical security for the meters, privacy and security for the data, and complete lifecycle security through device management. All of the technology features comes with a strong ecosystem and partnership of utilities, silicon vendors, metering companies, and the business-specific hidden partners. So what Pelion does is it removes the complexity and makes metering seamless. What's the advantage of Pelion is that it allows you to choose any smart meter with any connectivity, and it enables the connection of that smart meter a secure connection of that smart meter into any head-end system, which is the business application for smart metering. So the complexity of choosing a smart meter, of connectivity, bringing multiple vendors together, we remove that complexity. We provide you with a single glass of pane with a life cycle security and management. All of that comes with a high level of security. Let's look at how the architecture looks, or how the end-to-end architectures from metering looks from a meter to the head-end system. From a communication technology perspective, let's take an example of cellular architecture. Cellular is becoming popular in water and gas metering. We're also seeing a lot of usage of cellular in the electricity metering. Similarly, the other connectivity technology is mesh that we can look at, but let's look at cellular right now. So you would have a smart meter. The smart meter would do metering, but it would also have a connectivity module. It's typically called as NIC, or network interface card. The network interface card would have connectivity, or a connectivity processor that allows the cellular connectivity, and over the cellular network it would connect to Pelion Device Management, where Pelion Device Management allows strong identity provisioning, energy efficient connectivity, making sure that you can connect any kind of meters to the web, firmware deployment and firmware update, along with high level of security. You can very easily connect Pelion Device Management to any hidden system or to any web applications of choice. Pelion Device Management comes in a different deployment options, whether it is on-premise, whether it is private cloud or public cloud, and it is optimized, or Pelion architecture in general is highly optimized for low power applications. Back to Kaushal.
Thanks, Mohit. Yeah, really compelling advantages there for Pelion with the flexibility, with the connectivity options and the head-end systems. Now let's zoom into the device itself, which in this case would be a smart meter. Essentially, you need to look at, when you pick a hardware platform, not just, what are the features on the MCU itself, but what kind of portfolio and experience from a solution standpoint does the company have? So this slide sort of summarizes Renesas's experience and solutions portfolio in this space. Renesas is a leading supplier to the metering space. We have about over hundreds of millions of units deployed globally. We're also associate members of several different consortiums and standards bodies worldwide, which is shown on the slide. And then complete reference solutions are available in place, because that's one of the key things when it comes to developing a metering platform is how can we get started in terms of reference designs and things like that. And as I also mentioned earlier, as part of the Renesas RA roadmap, we also have some attractive application-specific standard products for e-metrology that are coming out over the next year or so. But from a generic microcontroller standpoint, what are some of the compelling features that we should look at when it comes to metering? So as an example here, this is an RA6 device. So what are some of the features there, right? So it of course comes with robust security, right? Highest level of security, ability to boot securely, as well as the security protocols which come supplied and supported with the combination of the device and FSP. It's a low power architecture, plus the power design is fairly simplified, which actually has resulted in reduction of a DC-DC stage, overall BOM savings from a hardware standpoint. It also this device supports robust capacitive touch capability. And capacitive touch has an interesting application with metering because it provides improved isolation of push buttons, as well as it can be used for anti-tampering type of applications. And then, last but not the least, just to reiterate, that this is part of a scalable and open portfolio. So you're really future-proofing your design in the future if you want to add features or go up in terms of complexity and feature set, or even if you want to reduce the feature set and basically do derivative options for your platform. That's also very possible with this microcontroller family. So over to Mohit again to talk a little bit more about the cloud side.
Thank you so much, Kaushal. So, specifically in metering and also in a lot of other verticals and areas, it's important that you have flexibility and scalability and different deployment options. Pelion allows multiple deployment options. You can choose any cloud providers of your choice. You can have private cloud or public cloud. But most importantly, it allows you to deploy Pelion Device Management on premise, specifically for metering, where typically the environment is highly regulated. We provide the same level of feature set both on cloud and on premise. So you can take advantage of on-premise deployment option for Pelion Device Management, specifically for metering market. So Pelion and Renesas, allows you to have a secure IoT deployment of meters and any other IoT devices. We provide end-to-end security. It starts with having a hardware root of trust that is ensured using platform security architecture and using Renesas RA platform and their support for platform security architecture. Pelion ensures that there is a trusted authentication during onboarding of those devices into a network. Once the devices are securely onboarded and the legitimate devices are connected, Pelion ensures that there is a secure data communication to the on-premise or to the cloud. And it also allows to have secure firmware update so that if there is any security flaw or a device flaw, you can fix it using firmware update. Pelion also allows you to do in-field certificate management, and that ultimately allows you to revamp your security and also do the lifecycle management for the smart meters. So all in all, what we are doing with Pelion and Renesas is solving an IoT dilemma. We want you not to worry about having a standard-based solution, making sure that you can reuse your development. We don't want you to worry about the cost, whether it is development or operational, and we don't want you to worry about security. We provide all of that integrated with Pelion and Renesas. We want you to focus on the need of business. That's where there is the most value and return on investment so that you can focus on shorter time to market, lowering the cost, making sure that you compete using new business models and keep up with the future technology challenges. We have a lot of resources available, and Kaushal will going to summarize some of those resources.
Thanks, Mohit. Yeah, so as Mohit pointed out, right, there's a lot of resources available both on the Renesas RA and Pelion as well as the combined solution. So the first link here, which is essentially a GitHub link, is essentially a complete, getting started guide as well as a step-by-step instruction set on how do you get the Pelion client running on the Renesas RA MCU family out of box. The second link there, talks a little bit about, the Renesas and Pelion solution, gives you more information on the overall solution, as well as I would highly recommend going to that page, and there is a video that essentially introduces where an engineer walks through the step-by-step instructions that are outlined on GitHub in terms of, how do you take the kit, how do you take the core components of the Pelion platform, and then how do you get the platform running on the Renesas RA family in a matter of minutes. The third and fourth links there are, about the Renesas RA MCU family. If you want to learn more about the MCU family itself, the features, the different device options that are available, as well as the supporting third-party ecosystem which is the fourth link there, and we have a variety of options from an ecosystem perspective, and our ecosystem partners provide essentially building blocks for different aspects of system design, whether it's connectivity, cloud, HMI, etc. And then finally, feel free to reach out to either me or Mohit. Our email addresses are there if you have any questions. Um, and we hope you enjoyed this presentation. And I'd like to thank everybody for your time. And please stay safe.
Thank you so much. It was great talking to you. And as Kaushal mentioned, please reach out to us if you have any question or want to learn more. Thank you.